everyone. Today I'm explaining the science behind non-stick cookware or BTFE, commonly known as Teflon. So BTFE or polytetrafluoroethylene was invented by Roy Plunkett on accident in 1938 when he trying to figure out BTFE as a gas for the fridge, but it resulted in a solid substance, and that is BTFE. PTFE is commonly used in cookware, medical devices, or electrical installation, but the most common thing is cookware. So these are a couple of unique properties of PTFE. So it got a non-stick surface, high thermal stability, chemical inertness, low friction coefficient. It's also hydrophobic and oleophobic. So this is the molecular structure of PTFE. So it is the polymer consists of carbon and fluorine atoms. The carbon backbone is surrounded by the fluorine atoms, and the fluorine atoms act as a shield outside and to prevent couple chemical reaction with the carbon inside. And the carbon fluorine bond are very strong, which means it's hard to break. So that's why it has that inertness ability. So friction and heat resistance. So it has a low surface energy, has approximate 19 dynes per centimeters. So surface energy, if the plastic got low surface energy, the liquid will beat up. That's why you see when you put a pan, when you drop the water on it, it will form like droplets. And it has a and BTFE also has a low coefficient friction coefficient at around 0.05 to zero point 0.1. It has a high thermal stability. It's up to 260 degrees Celsius working temperature, and it start to degrade at 350 degrees Celsius. So why BTFE is so commonly used in cookware? Because of its molecular structure and its ability to repel food particle from its smooth surface, and that's why it can reduce oil usage and make cleaning make easier. So here are a couple environmental and health considerations for PTFE. So even though PTFE are really useful, it was once dangerous since it was manufacturing used with the substance called PFOA. So PFOA was used to make the process of making PTFE much smooth and easy. But sometimes the trace of PFOA remain in the paint and is dangerous. Old, scratch, or worn out PTFE pans can indirectly increase the risk of overheating, which means it can release toxic fumes, and that's really dangerous. Um, so those are the reasons why ceramic or silicone coatings pans are growing in popularity nowadays. So this is my video to explain the characteristic of PTFE.
Hey everyone, today I'm gonna do an experiment to test the friction coefficient between three materials, which is ceramic, stainless steel, and BTFE coating on this pan. So what I'm gonna do is I'm gonna just slide this lighter off the surface, and depend on what's the angles, um, the material we can say that has the low friction coefficient if they got the low angles. So let's start off with this plate. my assistant, my cameraman, gonna tell me what angle they're gonna slide off. So I'll put the lever right here.
$22.
22. Okay. That was ceramic, by the way. Ceramic pan, ceramic plate. Okay. Moving on, we have this stainless steel cutting board. Let's do this. Okay.
It's like 16.
16. And finally, we'll have this BTFE coating pan, baking pan.
Starting to slide around like 9.
9. So we have our answer. 9 degrees, 16 degrees, 22 degrees. As you can see, this coating pan got the lowest friction coefficient. Thank you.
There you go. And these are my reference for the project. And thank you for listening.